Hello, this is Mr. Stansbury. I'm going to take you through the notes on more features of rational functions. At the end of this, you should be able to say, I can identify key characteristics of more complicated rational functions to graph the functions, and I can explain why the graph of a rational function has a whole or vertical asymptote. Okay, so we're going to kind of get more into the definitions of some of these things that we've already been using. But first one, asymptote, a line that a graph will get really close to but never actually reach. For rational functions, a vertical asymptote is what makes the denominator equal to 0, because we know we can never divide by 0. So that's our vertical asymptote. Horizontal asymptote kind of depends. If the degree in the numerator is smaller than the degree in the denominator, then there's an asymptote at y equals 0. If it's equal to, there's an asymptote at y equals the ratio of the leading coefficients, and we'll take a look at that in our first example here. And if it's 1 more than, there's no horizontal asymptote, but a slant asymptote instead, which means like instead of a vertical, or sorry, excuse me, instead of a horizontal line, it's going to be some kind of diagonally, line, something that's got a slope on it. Okay? The equation of the slant asymptote is the numerator divided by the denominator. We'll take a look at one of those too. Okay? One last thing is holes. There will be a hole in the graph if there are common factors in the numerator and the denominator, not including just the constants. So common factors. Okay, we'll take a look at that also, I believe, in our first example. Okay, example 1, graph the rational function, then identify domain, range, and end behavior. And we have this lovely looking thing here. Okay, so first off, if you'll remember, if the degree in the numerator is equal to, there's an asymptote at y equals the ratio of the leading coefficients. Okay, so leading coefficient here is 1. Leading coefficient here is 3, so we're going to have an asymptote at y equals 1/3. Okay, so if we're drawing that here, if we're calling this 1, so then at 1/3 is going to be right down just up above our x-axis, right? Okay, so there's our horizontal asymptote. Now to figure out the vertical asymptotes, or asymptote or asymptotes, we're going to want to factor this denominator out. And then to figure out the holes, we'll want to factor out the numerator as well. So let's factor these things out. So we've got x squared minus 2x minus 8. So factors of 8 that have a difference of 2. So factors of 8 are 1 and 8, and they're 2 and 4. And 2 and 4 have a difference of 2. So we're going to call that, it's going to be x and x. And then we're going to have what? Say 2 and 4. They have to add up to -2, so it's going to be -4 and +2. So that's the top factored. The bottom, if you'll notice, they all have a factor of 3. So let's get the 3 out. So we'll do 3 times x squared. You know what? Let's put this over here where it belongs. I'm going to get rid of this. And we'll rewrite that here. So we've got y equals 1/3 is our horizontal asymptote, right? And then this one here, we can factor 3 out, so we have x squared plus x minus 2. So then we got to come up with the factors of 2 that have a difference of 1, right? So only factors of 2 are 1 times 2, and they do happen to have a difference of 1. So then our denominator is now going to be x, and then one of them is going to be 2, and one of them is going to be 1, right? So they have to add up to +1, so it's going to have to be +2 and -1. Okay? So with this denominator all factored out like this, now we can actually figure out what our vertical asymptotes are going to be, right? So vertical asymptotes are going to be when we have x plus 2 equals 0 and x minus 1 equals 0. So subtract 2 from both sides, x equals -2. Add 1 to both sides, x equals 1, right? Now, those in theory are going to be our vertical asymptotes, but we also have to factor into this whole idea the holes. These two are the same factors, and if you'll remember from back here, if you have one more, let's see, oh no, it's down here. Hole, there's going to be a hole in the graph where there are common factors in the numerator and the denominator. Okay, so we do have our common factors here, x plus 2, x plus 2. So this one right here, this is actually going to be where the hole is. And then this x equals 1, that's where our vertical asymptote is going to be. Sometimes they do have a couple of vertical asymptotes. And we should hopefully look into one of those here. Okay, so those are our two asymptotes, and we know that there's a hole, and I'll show you what that looks like when x is -2. Okay, so now we want to just figure out what the rest of this thing looks like, right? So let's plug in, say if we plugged in 0 for everything, let's see what our y would be. I really think that's probably our easiest bet here. Okay, so we have, I'm just going to rewrite it down here because we got all this mess here. So we got x plus 2, x plus, minus 4, all over x plus 2, and x minus 1. Right, so we're going to plug, let's see what happens if we plug in 0 to this. So we get 2 times -4 all over 2 times -1. Right, so that gives us -8 over -2, which is simply 4. So if we plug in 0, we're going to get 1, 2, 3, 4. So we're going to get a point up here. Okay, I forgot one thing. We have that 3, that factor of 3 that we got out right here. So we're going to multiply this -2 times 3, which is going to give us -6, which is going to give us -4, positive 4 thirds instead of that. Oh, oops, that took out the whole graph, didn't it? Okay. Let me fix that. Was enough. All right, and then we are going, so now we are at 0, and then we're at 4 thirds, which is 1 1/3. So there's a point there. So that means this graph is going to come in here really tight like this, and then come down and curl through there, and then get really close to this asymptote here as well. And then guess what? It's going to be the same thing over here. We're going to go, from here, we're going to go down 1 1/3, which is going to be right there. So this graph over on this side is going to look like this. And again, this is getting really close to this asymptote, but never actually hits it. Okay? Now, we graphed it. Now find domain, range, and end behavior. Let's write that down. Okay, so here we go. Domain and range. So it goes forever never to the left, forever never to the right, everything except for 1. So we do all real numbers not equal to 1. And then the range goes forever never up, forever never down. It just never hits at 1/3. So it's going to be all real numbers not equal to 1/3. As x goes to -infinity, our y is getting really close to that 1/3, right? And then we got to go as it approaches this asymptote here. So as x approaches 1 from the negative side, remember this is the negative side and this is the positive side. So we basically find 1 and go over, find the graph, and then work back towards 1 from the negative side. This thing's going towards infinity, right? As we're approaching 1 from the positive side, so go over to the positive side, find the graph, work back towards 1. This is going towards -infinity, right? And as x is going towards infinity, f of x, or the y, is approaching 1/3. Okay? A hole at -2, so -1, -2. There's actually a hole right here. You signify that with a big open circle there. I know it looks kind of like a smiley face there because just the way it worked out, but that is where the hole is from the last one.
Jaden, what do you think?
Look at
God.
All right. Last example here. Example, well, it says example 1, but it's really example 2, isn't it? Let me write that on there. Okay. So, example 2, graph the polynomial function, identify domain range and end behavior here. Okay. Okay. So, we've got this one here. 2x squared plus 10x plus 8 over x plus 2. We're going to do the same thing we just did. Graph it, identify domain range, and end behavior. So, now if you'll remember this here, the exponent on the top is bigger than the exponent on the bottom. So that means if the degree in the numerator is 1 more than, there's not a horizontal asymptote, but a slant asymptote instead. And the equation of the slant asymptote is the numerator divided by the denominator. Okay, so then what we're going to want to do here is we're going to want to divide this by this. You could do, since we're x plus 2, since the x has got a the coefficient is 1, we could do synthetic division, right? We could do -2 in here, and then we're going to do 2x squared, 10x, and 8. There's no missing exponents, right? So we could just do synthetic division, make our life a little bit easier. If not, you can just do long division, and I'll show you what that looks like here in a second. But so bring the 2 down. -2 times 2 is -4. 10 and -4 is 6. -2 times 6 is -12, and that's -4. That's our remainder. This is our constant. This is our x. That right there, 2x plus 6, that is the equation of our slant asymptote. Okay, so that means we're going to go up 6. And then from there, up 2 over 1, up 2 over 1. We can also do the opposite, down 2 over 1, down 2 over 1. And then we make ourselves a nice little line here. Oops, I've got a little cheater way I can make a good line. Let's see if I can, there we go. All right, I think that's pretty close. Okay, so that is our slant asymptote. Okay, so that should actually be a dotted line. So let's see if I can't fix that a little bit. There's our dotted line there. So now it is a asymptote here. Okay, and then now let's see. We also know that x plus 2 can never equal 0. Right? So x can never equal -2. So at -2, there's also another asymptote here, right? Now to figure out where everything's going to be, like where, if it's going to be over here and over here or up here and down here, we just are simply going to plug in some numbers here, right? I always like to plug in 0 because that's pretty easy. If we plug in 0, we're going to get, the x's are going to go away, and we're going to get 8 over 2, right? So if we plug in 0, 8 divided by 2 is 4. So at 0, 1, 2, 3, 4. So we know the graph is going to be in here, right? Let's maybe plug in -1 just to see what we get. So we do 2 times -1. Oh, we really should, we got to factor this first and see if there's a factor of x plus 2 up here, because if there is, then that means there's also so let's factor this and see if there's a hole at all. So we can get a 2 out of the numerator. So we've got 2, and then we're going to end up with x squared plus 5x plus 4. And then on the bottom, we're going to have still our x plus 2, right? So let's see this here. Factors of 4 that add up to 5 are 4 and 1. So x plus 4, x plus 1 all over x plus 2. There's no common factor, so no holes in the graph. Okay, so we've got this one. Let's plug in. Now we can go through. Let's plug in -1 just because we forgot the hole. I forgot the hole, sorry. So let's just plug in -1 to kind of see where it's going to go in here. So 2 times, actually, you know, let's now that it's all factored out, this is going to be a lot easier to plug that in here. So -1 and 4 is 3. -1 plus 1 is 0. And -1 plus 2 is 1. So that's going to give us 0. So our other point is going to be there. So our graph's going to look something kind of like that-ish, right? And then it should be over here too, but let's just double check. Let's plug in -1, 2. Let's plug in -3, and it should be up here somewhere. So if we plug in -3 to this here, we get -3 and 4 is 1. -3 and 1 is -2. And -3 plus 2 is -1. So that's going to be -2 over -1, which is just 2. So over here at 3, we're at right here at 2. Our graph's going to look something kind of like that, right? Okay. All right. It's kind of a long video. Sorry about that. But that takes us through everything that we need to know for more features of rational functions. If you have any further questions on this, please feel free to ask in class. Thanks.